Okay, so let's take a look at Moon Cresta in MAME and see how the video hardware, at least the sprite hardware, works. So, started up MAME 64 with the debug option using the Moon Cresta G, Moon CRSTG ROM. And the first thing we're going to do is we're going to go ahead and find out the memory map for where the video or the sprite, the object, motion objects they're sometimes called, the sprite information is. And you can figure this out through the schematics, reading the MAME, the driver sources, but I cheated. I was lazy. I just Googled Moon Cresta memory map and clicked on the first one. And I found, here we go, Moon Cresta. And I find out that the object RAM is at 9800 through 98FF. So, you're going to close that down. Let's go ahead and put in new memory window, 0x98, and let's just make it just big enough to see the range. So there we go. This is all we care about. I'm going to move that over here, and I'm going to go ahead and start the game. Hit F5. And I'm just going to watch what's going on when I start the game. So and there we go. So already we see a bunch of data in these two lines. We see this, and certain pieces of data are moving, and those are probably the positions of the various sprites. So I don't know anything about the sprite hardware on this and how it works to make sense of the memory map. So I'm going to do what I often do when I have a problem and I have some way of manipulating the problem and viewing the results. I'm just going to literally manipulate numbers, or manipulate the RAM and see what happens as I do that. So I'm going to restart it here, and then I'm going to hit F8 to pause, and let's see what we have. Again, this row 9840 9850 seems to be active when those ships appeared. So I'm going to think that somehow these are the ship data. So I know there's going to be a couple numbers involved. There's probably going to be a X offset, a Y offset, and a sprite index that that literally is what sprite to draw. And there's probably going to be some color information or rotation information. So there's going to be at least, I believe, I could be wrong, but there's going to probably at least be 3 bytes associated with each sprite, maybe 4, maybe more. Let's go ahead and see what happens. So I'm going to go to this one, 9840, and I'm just going to manipulate the first number. It's a 78. And actually, if you look at these, you actually will see some patterns where you could actually kind of figure out what is what, at least what one value is. But let's just go ahead the old-fashioned try it and see what happens way. So I'm going to manipulate this 78, and I'm going to change it to something else. And note, I'm going to type it twice because in the emulation, for some reason, it doesn't seem to take until you hit it, put it in twice. I don't know the reason. It doesn't really matter. So I'm going to hit 78. Let's make that half. Let's make that, I don't know. Let's make that 40, which is approximately half. That's about 80. Let's make it 40. Oh, look at that. And that time it took right away. But it immediately went to the left. So let's add that back. Let's make that 80, and it went to the right. So we know this is the x coordinate for this sprite. All right. So I'm just going to write that down. Mark that 9840 is the x coordinate for this sprite. What's this next number? Well, let's make that. Let's switch from 10 to 11, and type it in twice. Oh, and the sprite changed. It's now a different sprite. I'm going to make it 13. Okay. Put it back to 10. So clearly this next byte is the sprite index. That is what picture of the sprite to draw. All right. Let's go to the next one, 03. Let's make it 04. Oh, and the color changes. So this is probably the color information for that sprite, because sprites can generally take on different colors. They may have a foreground, they may have a background, they might have multiple colors, but there's some description of what the colors are. So there it is. So now we have 3 of those bytes figured out. So let's go to the next position. 70. Let's switch this from 70 to 40. And it goes up. So I go, I cut it in half and it goes up. Let's cut it down to 10. It goes up even more. So this is clearly the y coordinate. Let's make it E0. It goes all the way to the bottom. So we know that the y coordinate, the lower numbers is at the top and the higher numbers at the bottom, just like we know that the lower numbers for the x are at the left and the higher numbers at the right. Okay, so we know now 4 attributes of this sprite. Let's go to the next one. 70. Let's switch that to 40. And we see here the next sprite, because this little object actually is made up of 2 sprites, moves. So I believe pretty safely that now it looks like that, and let's just alter the other numbers too. Let's 12 to 13, because sometimes the numbers corresponding to the sprites aren't contiguous, but in this case they are. So we see it's following the same patterns, and then we'll switch this to 30. So we see that there seems to be 4 bytes associated with each sprite. We have a x coordinate, a sprite index, color coordinate or color information, and a y index. And then it just starts with the next sprite. So let's do something fun here. Let's just add at the end. Let's add some numbers and see if new sprites appear. So we'll add, I don't know, let's add 20, 20, let's add 11, 20, and 20. Yep, and sure enough, another sprite appeared. So this block of memory appears to be 4 bytes per sprite, and that seems to be what it is. So let's clear out everything. Let's just put zeros across here. I'm just going to write zeros across everything. Let's go back to 9840, and let's set that to 50, 10, 04, 50. And we have a sprite here on the screen. Now, let's see what happens when we set this number to this y coordinate as we get closer to the top. So let's set it to, I don't know, set it to 10. Okay, let's get closer yet. Let's set it to 07. Okay, so 07, 07, remember we have to type it twice, 06, 06, 05, 05, and you see it's disappearing. It's getting cut off by this high score information. 04, 04, 03, 03, 02, 02, 01. It has 1 line left, and at 00, the pixel disappears. So the way one way of making the pixel disappear is setting its y position to 0, which makes sense when we look at the bug or the misbehavior of the program. What we found when we were watching that video is as these guys moved back off the screen, which is actually close to FF, they wrap back over here. So it makes sense that what the computer is doing, what the code is doing, and I have to check the code to make sure, but I'm almost certain that when the ships go all the way back, they finally disappear by setting the value to 0. And normally, when the game's working, they disappear because they're really up here hidden. But whatever is wrong in our circuit board is not causing that hiding to happen. So, very cool. Now you learned a little bit about object RAM and how to figure out, based on just the object RAM, just poking around and see what happens. And we understand the problem a little more. That is what's probably occurring in our hardware. That is the sprites, the sprite RAM and all that is probably working. They're being set to 0, but whatever hardware stops the sprites from being seen when they're in this position, this parking position we'll call it, is not working. Alright, thanks for watching. If you like this video, consider sponsoring our Patreon page. Thanks.